sorry, I reached the limit of the 15 minutes, so here we are going to continue with the same exercise. So I was clarifying when we can change straight from moles to atoms or moles to molecules. So if we have a compound which is made of more than one atom, that in that case we are talking about molecules together. So, and that's going to be most of the time. There are only few exercises. I think there was only one in which you were asked to calculate atoms from a single element like this one. So if you're given a formula like this one with a single element, in that case you can change from moles to atoms straight. Otherwise, we have to first calculate molecules and then look at the elements individually, as in this exercise is asked. So I'll read this part. Okay, so in this case we are using Avogadro's number to calculate the number of molecules. So we got molecules previously, so now we are saying, okay, if in 1 mole I always have 6.02 times to the 23, how many molecules am I going to have if I have 2.57 moles? So we just need to solve this calculation. 2.57 times 6.02, which is going to be 7.7. Once again, you might get different decimals depending on how many you were using in each step, so don't worry if we get slightly different decimals, that's fine. In this case, as long as you have the 7 and you have the 23, your exercise is going to be correct. So don't worry too much about the little differences in the numbers you might get from one to the other. Okay, so this is the number of molecules that we have on that whole compound, nitric acid HNO3. However, the exercise is asking me to calculate number of atoms of each element. So now in this case we have a new conversion factor based on my formula. So if we take into account our formula, which is HNO3, we just need to look at how many atoms we have. In this case, this is the representation of one single molecule, okay? And in each molecule I have 3 atoms of oxygen, I have 1 atom of nitrogen, and I have 1 atom of hydrogen. Okay, so those are the number of atoms per molecule. So that's going to be my conversion factor. So if I have my starting number, which is going to be 7.7, because that's the number of molecules that I've got previously, 7.7 times, oh my god, something is happening with my pen, 10 to the 23 molecules. So we are looking at molecules of the whole compound. So now my conversion factor in this case is just going to be what I know. I know that in one molecule, in every molecule, let's start with oxygen because we have 3 of them. So that will be a good example. So in every molecule of my compound, I have 3 atoms of oxygen. That's what I need to write as my conversion factor, because that's what I have from the formula. So this is taken straight from the formula. I have 3 atoms of oxygen in every single molecule of nitric acid. So that's what I'm doing. Again, if it's easier for you to look at it as a rule of 3, see it as that. I am saying, if in one molecule I have 3 atoms of oxygen, how many atoms of oxygen I have if I have 7.7 times to the 23 molecules together? Okay, so it's basically multiplying the number of molecules by 3. Yes, that's it. That's what we are doing. We are showing it step by step and very detailed, just for you to get a clear understanding of what's happening. If you are good with numbers, if you are good with these conversion factors and you find a fastest way of doing it, if you have a shortcut to doing it, go ahead, do it. Don't worry. There is not only one way to solve this type of exercises. It's totally up to you. As long as you are showing a clear process, clear steps, and correct conversion factors, that's what matters. But you can use shortcuts or other processes as long as they make sense. No, don't worry. They are totally welcome. Okay, so in this case, we just need to multiply the number we got previously by 3, which is going to be 2.3 times 10 to the 24. And now we are talking about single atoms. In this case, specifically, atoms of oxygen in my compound, in my initial sample of nitric acid. Atoms of oxygen. Another advice, every time you write a number, write it with units, because it's going to be easier for you to cancel units, to look at what you are calculating and what you are getting. So always use numbers with units to make it more clear and for you to make it easier and more organized to cancel and to get what you need to get. Okay, so in this case, I will just need to repeat this last step that I did, but multiplying it only by 1, because if you notice, we have 1 atom of hydrogen and 1 atom of nitrogen per molecule. So in this case, the number is not going to change. I am going to get exactly the same answer, 7.7 times to the 23 atoms of nitrogen and atoms of hydrogen as well. It's going to be exactly the same. And why is that? Well, if you notice, for every molecule, we have 1 atom of hydrogen. So if we have 10 molecules of this compound, we are going to have 10 atoms of hydrogen. In this case, we have a huge number, 7.7 times to the 23. So it's the same number of atoms of hydrogen and nitrogen. We always need to multiply if there is a different number. Like in here, we have a 3, then in that case, we need to multiply. Okay, I hope this clarifies a little bit what we have seen so far. This is all we have seen so far. If these key ideas are useful for you, these are going to be shown in the quiz that you have, so you can use them if you need a guidance and a reminder of how it works. So whenever you have a number, a starting point, try to find that first step. Don't stress too much if you have no idea how to start. Try to use what you have and get the first step done, and step by step you can figure out what to do. For example, in this one we have to do like 5 different steps. But how did I start? Okay, if I have milliliters, what can I do with those? If I have milliliters and density, so then okay, let's start. If I have milliliters, I have volume. If I was given the density, I can get mass, and after that you can continue figure out steps. So use this as a guidance if it works for you. If not, that's totally fine. Find the easiest way for you to handle all of these exercises. There were in here some steps, so read carefully, pay attention to what is given and what is asked. In some cases you might need a couple of steps to try to plan a strategy and try to solve. And always look back and check and interpret. I love this question, does it make sense? Because when students propose funny conversion factors, that's why I ask all the time, because I have seen many funny conversion factors. For example, I have seen 1 gram equals, for example, in here I have seen, I don't know, 1 molecule equals maybe 1 gram, I have seen. Or with the molar mass, I have seen the students switch the units around. So always check your conversion factors and ask, do they make sense? Do they come from a equality that makes sense? So always check your conversion factors and make sure that they make sense. Examples of what I have seen in quizzes, I have seen conversion factors like 1 gram equals 3 atoms. Okay, that definitely is not correct. 3 atoms don't weigh 1 gram, definitely not. Or maybe 1 mole equals 1 gram. that's probably not going to be correct either. Not in compounds that we are going to see definitely. Okay, so always check that what you are writing as a conversion factor is an equality. It has to be an equality. And yes, let me know if you have any more questions, if there is any other exercise that you would like to clarify, we can clarify it. And yeah, that's it. All the best. So use these key ideas, solve these questions as practical exercises for you to prepare, and let us know if you need anything else. Thank you, ladies.